What if we could unlock the mysteries of the universe right from our home planet? With that intriguing question, let's start our cosmic journey. Our universe, this vast expanse of space and time, filled with galaxies, stars, planets, and more, is a treasure trove of mysteries. For centuries, humans have looked up at the sky, wondering what secrets it holds. Now, we have the tools and technology to delve deeper than ever before. Enter NASA's Interstellar Mapping and Acceleration Probe, or IMAP, a mission set to launch in September 2025. IMAP is not just a spacecraft. It's a detective, a pathfinder, a beacon in our quest to understand the universe. Its mission? To study the acceleration of energetic particles and the interaction of the solar wind with the local interstellar medium. Imagine the Sun, our very own star, constantly emitting a stream of charged particles known as the solar wind. This wind creates a sort of protective bubble around our solar system, called the heliosphere. But what happens when this solar wind meets the interstellar medium? The stuff that fills the space between the stars. That's where IMAP comes in. IMAP is designed to provide unprecedented insights into these cosmic interactions. It will help us understand how solar and cosmic particles are accelerated, potentially shedding light on phenomena like cosmic rays and space weather. It will map the boundaries of the heliosphere, giving us a better understanding of our place in the cosmos. In essence, IMAP is our ticket to understanding not just our solar system, but the wider universe. So are you ready for a cosmic journey with IMAP? Let's dive into our top 10 insights. At number 10, we have Understanding Space Weather. The Interstellar Mapping and Acceleration Probe, or IMAP, is geared up to provide critical insights into the realm of space weather. But what is space weather? It's the varying conditions in the sun's magnetic field, wind, and radiation. These conditions can affect not only our Earth's magnetic field and atmosphere, but also our technology and even our health. Space weather can interfere with satellite systems, communications, navigation, even power grids on Earth. And for astronauts out there in the cosmos, understanding space weather is even more crucial. The IMAP mission will study these solar conditions, helping us understand and predict space weather patterns. This knowledge will not only aid in safeguarding our technology, but also in planning safer space missions. This understanding could be a game changer for future space missions. Number 9 on our list is Monitoring Solar Activity. The IMAP mission, in a fascinating partnership with NOAA's space weather follow-on Lagrange 1, will be keeping a close eye on the sun's activity. This collaboration aims to gather essential data on solar flares and coronal mass ejections, those spectacular eruptions of massive amounts of matter and electromagnetic radiation from the sun's corona. These solar phenomena, while stunning, can pose significant threats to our modern technology and the safety of astronauts. By monitoring solar activity, scientists will be able to gain a deeper understanding of these powerful solar outbursts. This knowledge is not just for the sake of curiosity, it has a practical side too. With this data, we could potentially predict and prepare for solar storms, a significant step towards protecting our technology and astronauts who dare to venture into the great unknown. This data could help us predict and prepare for solar storms, protecting our technology and astronauts. At the 8th spot, we have Studying Earth's Outer Atmosphere. Now, you might be wondering what's so fascinating about Earth's outer atmosphere. Well, it's more than just a layer of gas. It's a vital shield, a protective bubble that keeps us safe from the harmful radiation of space. Enter the Carruthers Geocorona Observatory, a companion on this exciting journey with IMAP. Named after the pioneering African-American astrophysicist, George Carruthers, this mission is set to study our planet's outer atmosphere. The observatory will delve into the mysteries of the geocorona, the outermost part of our atmosphere that merges with the interstellar space. By studying the geocorona, we can learn about the composition and behavior of this protective layer, how it interacts with solar winds, and how it shields us from cosmic radiation. This exploration isn't just a scientific endeavor, it's a quest to better understand our home, to peel back the layers of the unknown, and to comprehend how we fit into the grand scheme of the cosmos. Such insights could lead to a deeper understanding of Earth's place in the cosmos. Number 7 is Mapping the Heliosphere. The heliosphere, often described as the sun's protective bubble, is a vast, invisible field that shields our solar system from interstellar radiation. So, how do we map something we can't see? Enter the Interstellar Mapping and Acceleration Probe, or IMAP. This ingenious spacecraft, set to launch in September 2025, is designed to do just that. Using cutting-edge technology, IMAP will trace the acceleration of energetic particles and monitor the interaction of the solar wind with the local interstellar medium. By doing so, it will create a detailed and dynamic map of the heliosphere. This isn't just a map in the conventional sense, though. It's a comprehensive understanding of our solar system's protective shield, its fluctuations, and its interactions with this cosmic environment. This map could revolutionize our understanding of the solar system's boundaries. Coming in at number 6 is energetic particle acceleration. This is a phenomenon that has intrigued scientists for a long time. With the launch of NASA's IMAP mission, we are one step closer to understanding this extraordinary process. IMAP is designed to study the acceleration of these particles, which are often propelled at nearly the speed of light. These accelerated particles have the potential to produce cosmic rays, some of the most energetic and mysterious phenomena we know of in the universe. Understanding the mechanisms that drive this acceleration could provide us with valuable insights into the creation of cosmic rays. This could, in turn, unravel the mysteries surrounding these highly energetic particles. So, as we look up to the stars, we can't help but marvel at the incredible processes unfolding in the vast expanses of our universe. These findings could unravel the mysteries of one of the most energetic phenomena in the universe. At the halfway point, at number 5, we have solar wind interaction. The Interstellar Mapping and Acceleration Probe, or IMAP, will investigate the intriguing interaction between solar wind and the local interstellar medium. Solar wind, a stream of charged particles flowing out from the sun, interacts with the interstellar medium, the stuff that fills the space between the stars. This interaction is a dynamic dance, a cosmic ballet if you will, shaping the protective bubble around our solar system known as the Heliosphere. IMAP, stationed at the Sun-Earth Lagrange point 1, will provide a unique vantage point to observe and study these interactions in detail. By analyzing variations in solar wind, IMAP will help us understand how solar and interstellar forces shape our solar system. This mission is not just about observing, it's about understanding. Understanding the forces that drive space weather, influence cosmic radiation, and ultimately affect conditions on Earth and throughout our solar system. This knowledge could redefine our understanding of the solar system's dynamics. Number 4 on our list is interstellar medium properties. Now, what's the interstellar medium, you might ask? It's the stuff that fills the space between the stars. It's not an empty void as we might imagine, but a complex mix of gas, dust, and cosmic rays. This material is incredibly important because it's the raw material from which stars, planets, and ultimately life are formed. Now here comes the role of NASA's IMAP mission. IMAP will probe into the properties of this interstellar medium. It will help us understand the composition, density, temperature, and state of ionization of this mysterious stuff. In other words, IMAP will give us a closer look at the basic building blocks of the universe, helping us to understand how it evolves over time. This mission will also provide crucial insights into the life cycle of interstellar dust, from its birth in dying stars to its incorporation into new planetary systems. Armed with this knowledge, scientists will be able to make more accurate models of the galaxy and the universe. These findings could change our perception of the space that surrounds us. Coming in at number 3 is cosmic ray origins. Cosmic rays, those high-energy particles from space that incessantly bombard our Earth, are still shrouded in a cloak of mystery. These particles are believed to originate from some of the most violent events in the cosmos, like supernovae or the collision of galaxies. But the exact mechanisms behind their creation and acceleration remain elusive. This is where IMAP steps in. With its sophisticated instruments, IMAP will closely study these cosmic rays, tracing their journey back to their birthplaces. It will probe their energy, direction, and composition, seeking answers to the long-standing questions about their origins. Why does this matter, you might wonder? Well, understanding the origins of cosmic rays is not just about satisfying scientific curiosity. These particles play a crucial role in shaping our universe. They can influence star formation and can even affect our own planet's atmosphere. So, IMAP's mission to trace the cosmic ray origins is truly significant. It's like peeling back the layers of an interstellar onion, each layer revealing more about the violent and energetic universe we live in. Unraveling the origins of cosmic rays could shed light on the most violent events in the universe. Our runner-up at number 2 is interstellar boundary exploration. This is where things really start to get interesting. The Interstellar Mapping and Acceleration Probe, or IMAP, will journey to the outermost reaches of our solar system, where the sun's influence begins to fade and interstellar space commences. This boundary, often referred to as the heliopause, is a fascinating and complex region. It's like a cosmic weather front, where the hot solar wind from our sun meets the cold interstellar medium. This is a region of space that we know very little about, mainly because it is so far away, about 100 times further from the sun than the Earth is. IMAP's mission is to map this boundary, to understand the nature of the interactions that occur there. The data it gathers will help us learn more about how cosmic rays are accelerated, how the solar wind interacts with the interstellar medium, and what this all means for our understanding of the universe. This exploration could redefine the boundaries of our cosmic neighborhood. And at number 1, the most significant insight is the sun's protective bubble. This fascinating sphere of influence, the heliosphere, forms the outermost layer of the sun's atmosphere. It's like a cosmic shield, protecting our solar system from high-energy interstellar particles. The heliosphere is a vast, teardrop-shaped region filled with solar particles, extending well beyond the furthest planets in our system. It's created by the sun, which emits a constant outflow of charged particles known as the solar wind. This wind creates a bubble in the interstellar medium, the space between the stars. However, the heliosphere isn't just an empty bubble. It's filled with the solar wind, which travels at supersonic speeds until it reaches a point far from the sun, where it slows down and heats up, forming a shock wave known as the termination shock. Beyond this point, the wind slows down even more, changes direction, and forms a boundary known as the heliopause. This is the edge of the sun's domain, where the solar wind finally gives way to the interstellar medium. IMAP, with its suite of 10 high-tech instruments, will study the heliosphere in unprecedented detail. It will map the boundaries of this protective bubble and examine the processes at the edge of our solar system. By doing so, it could reveal how the sun's protective bubble keeps out most of the galaxy's high-energy cosmic radiation. Understanding the heliosphere is crucial, not just out of scientific curiosity, but for practical reasons too. This cosmic radiation, which the heliosphere shields us from, is harmful to spacecraft and astronauts. It can damage electronics, interfere with communication systems, and pose a health risk to astronauts on long-duration space missions. This knowledge could be the key to safe interstellar travel, opening up new frontiers for humanity. As we venture further into space, we'll need to understand the environment we're stepping into and how to protect ourselves from it. And that's why the sun's protective bubble is our number 1 insight from the IMAP mission. So there we have it, the top 10 insights from the upcoming IMAP mission. As we journey through the cosmos, we are constantly uncovering new layers of knowledge. The IMAP mission is a prime example of this relentless pursuit of understanding. Its insights into space weather, solar activity, and Earth's outer atmosphere will not only provide valuable information for protecting our technology and astronauts, but also deepen our understanding of the sun's influence on our home planet. The mission's exploration of the heliosphere, the acceleration of energetic particles, and the interaction of the solar wind with the local interstellar medium will shed light on the very dynamics of our solar system. The data gathered will help us to map the heliosphere and understand the mechanisms that shield us from cosmic radiation. From the origins of cosmic rays to the properties of the interstellar medium, the IMAP mission will uncover clues about the universe that are currently beyond our grasp. As we probe the interstellar boundary and the sun's protective bubble, we are essentially probing the edges of our knowledge, pushing the boundaries of what we know about the universe. These insights are not just about the present, they are about the future. They lay the groundwork for future missions, future discoveries, and future breakthroughs. They will inform the work of space agencies around the globe, from NASA and ESA to JAXA and SpaceX. They will guide the next generation of explorers, whether they're aiming for the Moon, Mars, or beyond. With every mission, with every probe, with every bit of data, we come one step closer to answering some of the biggest questions about our universe. And though the vastness of space may be intimidating, it's also incredibly exciting. The future of space exploration is bright, and it's filled with possibilities. It's a future where we continue to learn, explore, and discover. It's a future where we continue to push the boundaries of our knowledge and our capabilities. With missions like IMAP, we're not just exploring space, we're unlocking the secrets of the universe itself. Before we wrap up this cosmic journey, we'd love to hear from you. If this IMAP mission has sparked your curiosity and you've learned something new about our universe, please give this video a like. Your support helps us continue to bring you these fascinating insights. We're also eager to hear your thoughts. What was your favorite insight? What new questions do you have? Share your opinions in the comments below. And don't forget, if you want to keep exploring the universe with us, be sure to subscribe to our channel for more content like this. Finally, we believe that the wonders of the universe should be shared. So don't hesitate to pass this video on to your friends and family. Let's inspire more people to look up at the stars with wonder and curiosity. Thanks for joining us on this journey. And as always, keep exploring.